session, we will be discussing expected value and variance of the discrete random variables. So let us first start with the expected value. Expected value of a random variable. It is also sometimes called as expectation of a random variable. You can also say to be mean value. So expected value of a random variable is also known as expectation of a random variable, or you can say mean value of the random variable. You can see these three terms in the book for the expected values. The expected value of a random variable is denoted by the symbol capital E and in the bracket the random variable x, whose expected value or whose mean value is to be calculated. And another symbol that is used for the expected value of a random variable is nu x, where this x is a random variable whose expected value or mean value is calculated. And the formula to calculate the expected value is summation x multiplied by the probability when the capital random variable x takes the small value small x, and the small x varies all over the range of capital random variable x. Now let me take an example to explain you this formula. So this is the example. We are given with a random variable x which have the following PMF. And in this example we need to calculate the expected value of x in the A part. So let us do it. Now here we need to find the expected value of x. So you must remember this formula for the calculation of expected value of random variable. So the formula for calculation of expected value is this, where x varies all over the range of random variable x. And you must note that, as I have told you, this formula is valid for the discrete random variable. And since you know that PMFs are defined only for the discrete random variable, so the x, capital X, is the discrete random variable in this case. So we are able to use this formula in this case. So how to use this formula is that you just need to add all these x multiplied with their respective probabilities. In this case, the first value is 0 and its respective probability is 1 by 4. Now the second value that x takes is 2. Now we will multiply it with its respective probability, that is 2 by 4 in this case. Now the third value that x takes is 3 and its respective probability is 1 by 4. So you can just see that I have multiplied the x with its respective probability and just add all the values. So here I will get 0 and in this case I am going to get 2 by 2 and it's 1 plus 3 by 4. It comes out to be 7 by 4. So in this case the expected value of random variable x is equal to 7 by 4. So I can just write that E of x is equal to 7 by 4. So this is a simple method to calculate the expected value of any random variable, or more precisely I can say expected value of any discrete random variable. So now let us discuss about the variance of the discrete random variable. Now variance of a random variable is denoted by the symbol VAR and in the bracket random variable whose variance we are calculating. Or alternatively you can use the symbol sigma square x. Now the formula to calculate variance of a random variable is variance of x is equal to expectation of x minus nu x whole square. That is, to calculate the variance of a random variable, you need to find the expectation of this expression where x is a random variable and nu x is expectation of that random variable. Now you may be worried that how we will calculate this expectation. Now this is too simple, as we have seen earlier that when we need to calculate the expectation of a random variable, then we have just multiplied the values that this random variable can take with its respective probabilities and just add it. So to calculate the expectation of this expression, you just need to do uh, you just need to put values that this random variable, in this case x, takes in the expression, and then multiply it with its respective probabilities, and then add all of them. So let us just see this by the example that I've taken earlier. So now here we need to calculate variance of random variable x. So first of all, I will write the formula for this. So the formula for variance of x is expectation of x minus nu x whole square. We need to find the expectation of this expression. So first I will note the expression that I have is x minus expectation whole square. So now let us first put the first value of x in this expression, which is 0 minus, and this expectation that we have calculated in the first part is 7 by 4. So it's 0 minus 7 by 4 whole square. So this is the expression. And now I will multiply it with the respective probability, which is 1 by 4. Now similarly for the second term, put the second value of x in this expression, which is 2 minus expectation, which is 7 by 4 whole square, multiply by with the respective probability 2 by 4, plus the third value is 3 minus 7 by 4 whole square, multiply by with the respective probability 1 by 4. Now solving this, we will get 7 square upon 4 cube, 2 upon 4 cube, 5 square upon 4 cube. Solving, we get it's 25, and we will finally get 76 by 64. So this is our variance of the random variable x. Again, note that here we have calculated the variance of a discrete random variable. So now let us discuss some properties of expectation of x and variance of x. Properties for expectation of a random variable, and note that these properties are valid for both discrete and continuous random variable. In the next session, when I will be discussing the expectation and variance of continuous random variable, then again I am going to mention the same properties there also. So the first property says that expectation of a multiplied by random variable x is equal to a into expectation of random variable x. Here a is a constant, real number and x is a random variable. For example, if in previous example where we need to calculate the expectation of x, if someone asks you to find expectation of 2x, then your answer will be 2 multiply expectation of x, and the expectation of x was 7 by 4, so it would be 2 multiply 7 by 4 comes out to be 7 by 2. If someone will ask you about expectation of x by 2, then it would be e of x by 2, which would be 7 by 4 by 2, comes out to be 7 by 8. In a similar manner, you can have any constant here. Now let us move on to the second property, which is expectation of x plus y is equal to expectation of x plus expectation of y, where x and y both are random variables. For example, if you know that from the previous example expectation of x is equal to 7 by 4, and let us assume that you know another random variable whose expectation is 3 by 4, then expectation of x plus y using this property is equal to summation of both of these, which is 7 by 4 plus 3 by 4 comes out to be 10 by 4, which is equal to 5 by 2. In the similar manner, if you know the expectation of the two random variable and you need to find the expectation of sum of that two random variable, then you can just add two of them. Or you can also extend this property to more than two random variable. If you need to find expectation of three random variable, then it will be also equal to summation of expectation of all three random variable. Similarly, this property is applicable to any number of random variable. Now let us move on to the third property, which is expectation of A is equal to A, where A is constant. That is, if someone asks you about expectation of 2, then it will be equal to 2. If someone asks you about expectation of 5, then it would be 5. Now using these properties, I can also add a general property, which is expectation of ax plus b will be equal to a into expectation of x plus b, where a and b are constants. That is, if in the previous question where we have just find the expectation of x, if someone asks you to find expectation of 2x plus 4, then it would be equal to 2 of expectation of x plus 4, which comes out to be 2 multiply 7 by 4 plus 4. Now you can solve this to get the respective answer. Now let me tell you how this property is derived. This is equal to expectation of Ax plus expectation of B. And now expectation of Ax is equal to A multiply expectation of X. And expectation of B is equal to B, which is equal to this. From this you can also say that expectation operator is distributive over addition, that we have seen in these two cases. Properties of variance of random variable. Again, note that these properties will be valid for both discrete and continuous random variables. So the first property for the variance of random variable is that variance of Ax is equal to A square into variance of X, where A is constant and X is a random variable. So similarly, if I will give you example from the previous question where we have calculated the variance of X and it has come out to be 76 by 64. If in this case you were asked to calculate variance of 2x, then it will be equal to 2 square into variance of x, which is equal to 4 into 76 by 64, coming out to be 76 by 16. Now let's move on to the other property of variance, which is variance of A is equal to 0, where A is constant. For example, if you need to calculate the variance of any constant that is like 2, then it would be 0. If you need to calculate variance of 10, then it would also be 0. So if you will calculate variance of any constant number, then it will come out to be 0. If I will generalize these two properties, then I can write collectively that variance of Ax plus B will be equal to variance of Ax plus variance of B and now using these two properties you can say that variance of Ax is equal to A square into variance of X, and variance of a constant is 0, so it comes out to be A square into variance of X. And now the third most important thing, which is not the property but you need to remember it, that variance of x plus y, where x and y both are random variables, is not equal to variance of x plus variance of y. It is related to the covariance of x and y, which we will discuss in the upcoming lectures. For now, you must note that this variance of x plus y is not equal to variance of x plus variance of y. So here our discussion of expectation and variance of discrete random variable is finished, and in the next lecture we will discuss expectation and variance of continuous random variables.